Okay, let us discuss this problem. So this says we have a piston cylinder arrangement. So this is the cylinder and this is the piston, and the initial height of this piston from the base is 1 meter, that is given to you, and this contains a diatomic gas at temperature 300 Kelvin. So you have been this piston, this cylinder system contains a diatomic gas, so contains a diatomic gas. And let us say initial height of this piston from the base is 1 meter. So let us call this height is h1. So h1 is 1 meter. And now the area is also given to you. So area of this piston is 1 meter square. So if I know the area, I know the h1, and basically I know the volume. So I can say V1 initial volume will be A times h1. Now the question says initial temperature is 300 Kelvin. So you have a temperature initially 300 Kelvin, and now this question says the temperature is now raised to the 400 Kelvin. So temperature is raised. So why? How you raising? At the constant pressure. So pressure is constant. So we are doing the isobaric process. So pressure is constant. So this means we have a isobaric process. So this is a isobaric process. So this is the isobaric process. And now final temperature T2, and that is 400 Kelvin. So T2 is 400 Kelvin. If now, so find the new height of the piston with the cylinder. So we have to find what is H2. Are you getting or not? That is, if I say V2, that is A times H2. We have to find H2. Simple. You see, this process is basically isobaric process. So if I apply PV is equals to nRT, this system is a closed system, so cylinder is closed. So if the cylinder is closed, I can say, if the cylinder is closed, I can clearly say number of mole is constant. So N remains constant. So N remains constant. So now if N is constant and pressure is also constant, so this is isobaric process. So pressure is constant, number of mole is constant, R is also constant. So now I can write V1 by T1 is equals to V2 by T2. Simple. So this is, now I know V2 is, from here I can write V2 is equals to T2 by T1 into V1. And our temperature T2 question says it is raised up to 400 Kelvin, initial temperature is 300 Kelvin, and final volume V1, and that is basically A times H1, and V2 I can write A times H2. So A times H2 is basically 4 by 3 A times H1. So if A cancels out, so now I can write basically here itself I can write H2 is equals to 4 by 3 times H1. So we have a relationship, H2 is 4 by 3 times H1, and the question gives me the value of H1. H1 is 1 meter. So now I can say H2 is basically 4 by 3 meter. Simple. Now let us read the next part of the question. So this has two parts. Next part says if the piston is now brought back its original height. So height is now 1 by 3. So this is the height is 4 by 3. Initial height was 1 by 3, and now this height is 4 by 3. So you have this piston is here. So this is the cylinder you have. This cylinder you have, and initial height it was 1 meter. So this is 1 meter, and after heating, now you have somewhere here. So height has basically changed, and this height is basically 4 by 3 meter. So this height is 4 by 3 meter. So this is 4 by 3 meter. So basically what you have done, you have raised this piston up. So this piston is going up, and now the question says this piston comes down. So it again gains the finally 1 meter value. So finally I can say it gains the 1 meter. Now see what the question says, another part. You have to calculate the temperature. Now brought back to its original height without any loss of it. So this point is important. Without any loss of heat. What is the new equilibrium temperature? So no loss of heat. This means dq is 0. So if the dq is 0, what is the process? If the dq is 0, process is basically adiabatic. Are you getting or not? So the process is adiabatic. So this means PV gamma is equals to constant. So PV gamma is constant. But now I have to find temperature, so I can change this equation in terms of T and V variable. So PV is equals to nRT. So P is equals to nRT by V. If I plug this value here, so this is nRT by V into V to the power gamma. This is constant. Now you see, I can write TV gamma minus 1. This is T, and nR is constant, so I will have a new constant. Let us call this constant is constant. So now I have to find temperature. So let us say right now we have a temperature. T is 400 Kelvin. Let us call this temperature is T2. And what is the volume? So volume right now we have A into H2, and H2 is 4 by 3 times H1, that is, I know the volume. And finally, what is the temperature we have to find out? That is T3, and the volume is V3 will be A times H1, because this becomes the original volume, so A times H1. If I apply this one, so I will have TV gamma minus 1 equals to constant, so T is 400 Kelvin into V, initial volume is A into H2 to the power gamma minus 1. This is equals to T3, and to V3 is A into H1 to the power gamma minus 1. If I solve this equation, so I will have A cancels out throughout. So I will have 400 H2 to the power gamma minus 1 is equals to T3 H1 to the power gamma minus 1. So now I can write T3. So I can write T3 is equals to 400 H2 by H1 to the power gamma minus 1. And you see, the gas is initially, it's given in the problem, gas is diatomic. So let me see, it's a diatomic or monatomic. So in the first part it is given, so this is a you can see here, so diatomic gas is diatomic. So basically Cp by Cv is gamma. So for diatomic gas, Cp is 7 by 2. So let us say I can plug this value here. So Cp is for diatomic 7 by 2R, and Cv is basically 5 by 2R. So gamma is, Cp by Cv. So this is 7 by 5. Are you getting or not? So what is gamma minus 1? So gamma minus 1 is 7 by 5 minus 1. So simply this is 2 by 5. So 2 by 5, that is 0.4. So you see, and what is H2 by H1? We have already calculated H2 by H1. You see here. So in the first part we have calculated H2 by H1. So H2 by H1 is 4 by 3. You check here. H2 is equals to 4 by 3 H1. So H2 by H1 is 4 by 3. So if I plug that value here, H2 by H1 is basically equals to 4 by 3. So now T3 will be 400, and this is 4 by 3. Gamma minus 1 I have already calculated, that is 0.4. So this is the final value of temperature. So you have a temperature, so I can write T3 is equals to 400 into 4 by 3 to the power 0.4. Basically we can calculate this value. So let us try to calculate this value. I have the calculator. So I have 400 into, so 400, let us say 400, so 0 is here, 0 multiplied by, so this multiplied 4 by 3, so let us say 4 divided by 3, so this is 4 divided by 3, and this raised to the power, so let us say first 4 by 3 raised to the power how much? So 4 by 3 raised to the power 0.4. So this is 0.4. So this is 0.4. Let us make one here also, so that things are easy. Now calculate this value. So this value comes out to be 448.78. So this is 448.78. So this is 448.78 Kelvin. Are you getting or not? Things are simple.